Welcome back to MicroDSP, where we use tiny projects to teach ourselves digital signal processing. In day 3.5, we define a buffer as a chunk of memory where we store audio samples for later use. Today we're actually going to use one in the simplest way possible, array indexing based delay. Now what we're doing here is taking in a WAV file, adding the delay, and then writing an output file using a plain array and basic indexing. The core idea of the delay here is we're taking the sample at current index n and mixing that with the sample at n minus d, with d representing the delay samples. So essentially, if the current sample index is greater than or equal to the delay samples, then a delayed sample exists. And if the sample index is less than the delay samples, then the delayed sample is simply 0, because it doesn't exist. For offline processing, the buffer is literally just the entire WAV file loaded into memory. We're going to write the output samples into another array and then just walk from sample index 0 to the end. And this is literally just time going forward. And the mixed computation will be the same as always. We'll then need to clamp these values together so we don't get any overflow or crunchy nonsense. If you're using C++ version 17 or later, you can just use the algorithm library with the std clamp method. In this case, we're using a signed 16-bit integer, so we're going to need to clamp the values to -32,000 and +32,000. Also, from here on out, for relevant projects, I'm going to start using a struct for the wave header, as it provides much more semantic clarity than if we were to just read the wave header byte by byte. And that's pretty much it. As always, the project will be on GitHub, which is linked in my bio, and keep an eye out for day 5 of MicroDSP. Stay wired.